In section 6.6, we're going to look at the last form of a linear function, and that is general form. So far, we've learned the slope-intercept form, which is the form y equals mx plus b, and we learned the point-slope form, which is y minus y1 is mx minus x1. And today we're going to look at the general form of the equation of a linear relation. The general form of a linear relation is the equation ax plus by plus c, where a is a whole number and b and c are integers. And so what is a whole number? A whole number, again, is the counting numbers 0, 1, 2, 3, etc. And the integers are 0, plus or minus 1, plus or minus 2, etc. So in this section, a, b, or c cannot be fractions, and a has to be a positive value. And as it says in the bottom of this slide, this section is just a bunch of manipulating of formulas. Okay, in this question, we are asked to write the equation in general form. So in part A, we are given the equation in the slope-intercept form. So general form is not allowed to have fractions. So the first thing we're going to do is get rid of our fractions by multiplying every term by 3. So 3 times y is going to be 3y. 3 times negative 2 divided by 3 is going to be negative 2x. 3 times 4 is going to be 12. Now in general form, we want to have our x, our y, and our constant all on the same side of the equation, equaling 0. And we want our x term to be positive, so I'm going to add the 2x to the other side. I'm going to subtract the 12 over and make it equal 0. And this is the equation of my line in general form. So these two equations are really representing the same line. They're just written in a different form. Okay, in part B, we are going to, first of all, distribute the 3/5 to get 3/5 x plus 6 over 5. And as you recall, we're starting in the point-slope form of the line, and we want to get it in general form. So I've distributed. Now I'm going to multiply every term by 5 to get rid of my fraction. So 5 times y is 5y. 5 times negative 1 is negative 5. 5 times 3x is going to give me 3x. And 5 times 6 over 5 is going to give me 6. And now we want to get all our terms on one side and make our x term positive. And since our x is positive here, I'm going to bring the 5y and the negative 5 over to the other side. So I'm going to have 3x, and I'm going to subtract the 5y over. And if I add 5 to 6, I'm going to get 11. And there would be the final equation. Again, this equation and this equation are exactly the same. They're just written in a different form. Okay, in our next example, we're going to determine the x and y intercepts of the line, whose equation is given by 3x plus 2y minus 18 equals 0. Then they want us to graph the line, and they want to verify that the graph is correct. So to begin with, let's do part A. I want to find the x-intercept. So for the x-intercept, I let y equal 0. So it's going to be 3x plus 2 times 0 minus 18 equals 0. Well, this part here, 2 times 0 just drops off, so I'm left with 3x minus 18 equals 0. I'll add the 18 to the other side, divide both sides by 3. I'll probably show that step. Whoops. Sorry about that, we had a little malfunction there. We'll just try that again. We'll add the 18 to the other side, divide both sides by 3, therefore x is equal to 6. So my x-intercept, the coordinate is 6, 0. To find the y-intercept, I'm going to let x equal 0. So my equation is going to be 3 times 0 plus 2y minus 18 equals 0. So again, this drops off. I'll add the 18 to to the other side, and if I divide both sides by 2, I get y is equal to 9. So the y coordinate would be 0, 9. Now, if we wanted to graph this, okay, I start with my x-intercept of 6, 0. 9 or 0, 9 is going to be somewhere up here. And if I draw that line, it's going to look something like that. And there would be the equation of that line. Now, how could I verify that this equation is correct? Okay, well, we could convert this to the form y equals mx plus b. See if we get a y-intercept of 9. And we could have a slope of 9 over 6, which would be, well, negative 9 over 6, which would be negative 3 over 2. So let's take this equation right here, and let's convert it to slope-intercept form. So again, 3x plus 2y minus 18 is equal to 0. So the first thing I'm going to do is add the 18 to the other side. So I'm going to get 3x plus 2y is equal to 18. And then I'm going to subtract the 3x over. And then I'm going to divide each term by 2. I'm going to get y is equal to negative 3 over 2x plus 9. And this matches to the same graph that I drew here. I have a y-intercept of 9. My rise is negative 9, my run is 6, so my slope is negative 3 over 2, and that matches to this equation right here. Okay, in our next example, we're asked to determine the slope of a line with this equation, and the easiest form to put this into to determine the slope would be the form y equals mx plus b. So again, I am going to subtract the 3x over and add the 16. So I've done two things at once. I've taken these two terms over to the other side. And now I'm going to divide each term by negative 2. So I'm left with y equals, and be careful with your signs, negative 3 over negative 2 is positive 3 over 2x, and 16 over negative 2 is negative 8. So here's my equation in the form y equals mx plus b. And now the slope is just the value in front of my x term, and it would be 3 over 2. Remember, the slope is not 3 over 2x, it's just the number in front of the x term, which is 3 over 2 in this case. Okay, in our next example, we have an application question, and it says Devin has $10 to purchase these items. Peanuts cost $2 per 100 grams, and raisins cost $1 per 100 grams. Generate some data for this relation. So we're going to graph the grams of peanuts and raisins he could buy if he chose to spend all of the $10. So again, raisins were $1 per 100 grams, and peanuts were $2 per 100 grams. So if he bought just peanuts, he would be able to buy 500 grams of peanuts and 0 grams of raisins. If he was to buy, say, 300 grams of peanuts, he would spend a total of $6, and so he would have $4 left, and he could buy 400 grams of raisins. If he bought all raisins, he'd be able to buy 1,000 grams of raisins, and that would be 0 grams of peanuts. So because we're graphing a line, 3 points is probably adequate enough. So let's look at graphing this equation, or this data, sorry. So we're going to need a set of data. So we're going to need a graph. Okay, and we have peanuts down here on the bottom. And I'm going to go 100, 200, 300, 400, 500. Zero and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1,000. This would be 800, 600, 400, 200, and this was our raisins. Okay, and first of all, we know that he could buy 500 grams of peanuts and 0 raisins. He could buy 0 peanuts and 1,000 raisins. And the other data we had in our chart was 300 peanuts and 400 raisins, which is right there. And again, these 3 points form a nice graph of a linear function. Now in part C, it says write an equation for the relation in general form. Well, before we can write the relation in general form, we have to write it in point-slope form and then convert it over, or we could write it in y equals mx plus b form and then convert it over. So if we did it in the form y equals mx plus b, first thing I need to do is find my slope, and my rise is negative 100, and my run is 500, or sorry, negative 1,000 and 500. So my slope is going to be negative 1,000 over 500, which is negative 2. And my y-intercept, if I set up the graph the way I did, my y-intercept b is going to be 1,000. So therefore, my equation is going to be raisins, which is my y variable, is going to be negative 2 times peanuts plus 1,000. Okay, that was part B. And part C, or that was part C, sorry. Part D, will Devin spend exactly $10 if she buys 300 grams of peanuts and 400 grams of raisins? Well, if she buys 300 grams of peanuts and 400 grams of raisins, yes, she will spend exactly $10. We have that right here in our table as one of our points. So yes, this is true. And the second part says, will Devin spend exactly $10 if she buys 400 grams of peanuts and 300 grams of raisins? Okay, well, that doesn't show up on our table, but if we even look at the graph, the point 400 and 300, so here's 400, 300 is right there, so that point doesn't fall on my graph, so that would not be possible. And again, if we did the algebra, if she bought 400 grams of peanuts, she would be spending $8, and that would only leave her $2 left to spend on raisins, so the most she could buy would be 200 grams, so no, this is not possible. Okay, that ends section 6.6, so there's your assignment. If you have any questions, feel free to check the answers on the website. And this concludes chapter 6.